Hello friends, welcome to the last video on chains on the LangChain series. So let's start without any delay. So in the previous videos, we have learned about sequential chain, parallel chain, simple chain, router chain and multi-prompt chain. So this is the last type of chain which is called custom chain. So custom chain is not a chain or a behavior that is provided by the LangChain by default. It is a way you can create your own custom chains. You can define your own behavior, transformations, side effect, or whatever you want. Here you can do any complex logic, a simple chain or parallel chain, anything you want. So we will be using the runnables provided by the LangChain to create these custom chains. So let's start without any delay. So here the first custom chain I will be creating by using runnable lambda. So you have already learned about runnable lambda. So it's nothing, just the same behavior that we have seen with the runnable lambda. As you know, runnable lambda can create any function into a runnable. It basically accepts a function. It can be a big function or a small or a lambda function, any function, and it converts that to a runnable. And as you know, any runnable function can be passed in a chain. So basically creating a chain is nothing but using a pipe operator to align these runnable functions so that input of one goes to another, right? So you can just create your custom chain using runnable lambda. So I have just created a simple example here. So this is my again string output parser, and this is my sentiment chain. As we are doing the same thing again and again, I'm just creating the same example again. Here it's my sentiment chain, and it just asks to classify the sentiment of a review, whether if it is a positive, negative, or neutral, and we want to return only one word in the answer by the LLM. So here I'm again creating a simple chain using this pipe operator, and as you can see, I'm doing the same things that we have seen above. Similarly, I have created a response chain in which I am asking the LLM to, as a customer support agent, and write a suitable response to the following review, and based on the sentiment. So basically, whatever sentiment this chain will return to us, it will be passed as an input to this response chain, and this particular chain will give us a review about according to the sentiment. Give us a response for that review according to the sentiment defined by the previous chain. Again, same thing. So here now I'm creating small functions that I will be using in runnable lambda to create my custom chain. So let's go through that. This is normalize review. So here I'm just doing nothing. Whatever input is being passed into it, I'm just taking the review out of it and just adding a date time to it. Then in the enrich with sentiment, whatever data is being passed to it, I'm just keeping that as it is and adding a sentiment using the sentiment by invoking the sentiment chain and passing the review from this data as an input to the sentiment chain. So as you know, my sentiment chain here, it needs a review as an input, right? So that's what I'm doing here. Now generate response. This is again using response chain, whatever is being passed in the data in the param. I'm just keeping it as it is using this, and I'm invoking the response chain which is here, and it takes two inputs, sentiment and review, right? So that mapping I'm passing here as the input. Then last final formatter. Here I'm just creating a response that I want to return to the user or consumers as a final response. So here I'm keeping the review, sentiment, response, and the metadata, like whatever metadata I want to keep, I'm just keeping that. Now using runnable lambda to create a custom chain is like pretty simple. So you have to just pass all the functions that you want to make runnables inside a runnable lambda. And as you have seen in the other examples, above examples, you just sequence them through a pipe operator. So it will just create a custom chain for you. So runnable lambda, what will happen? As you know, the first input that you will be passing while invoking this chain, custom review chain, this input, which is a review in the mapper format, it will be get passed to this normalize review method. So normalize review method, you will get a object which has a review in it, and it will just get the review, put the review, like it will just remove the blanks and put the review in this dictionary, and then it will add a received at date time, and it will just return this as output. Now this whole object as an input will get passed to this next runnable lambda in which enrich with sentiment. So it will get this whole object will get passed to as a param in this X. Now here I'm just keeping whatever is being passed, this review and received it as it is. I'm adding a sentiment with using a sentiment chain. Again, this whole object is again getting passed to the next runnable lambda, which is generate response, and which is here. Here I'm adding a response to it, and then it's getting, this whole thing is getting passed to this final formatter, which is returning me a final output. So once you execute it, let's try to execute it. Let me run it. Okay, my kernel is not enabled. Let me quickly do that. Let me enable the environment. Source when activate. Let's select the kernel. I guess I have to open the project again. Okay, now let's try to run it again. So if I run this block again, so you can see now the output is coming, right? So here this is the review, and this is obviously a negative review and the response. And let's scroll to the left more and more. And then we have our metadata, which is like process date, confidence, and everything that we were passing here, process state and confidence. So whatever output we are returning from the function, that will be getting returned to the user. So this is one way to create a custom chain. Now let's create a more complicated chain using runnable lambda and the runnable parallel to create more complicated chains. So here I'm again doing the similar thing. I'm just taking the same problem of review again. So here if you see, I have the parser, then I have a sentiment chain as we have created above to get the sentiment out of a review. Then I have a summary chain to get the summary using the review. Get the summary, get the summary of the review in one sentence. Then I have issues chain. This will exactly the key issues mentioned in the review, like whatever issues are mentioned in the review, I'm just getting out of that in this chain. This is the issue chain, and then I will be using runnable lambda and runnable parallel to create this chain. So here, if you will look into in this in detail, so this particular chain, it needs a review as an input. This particular chain also needs review as an input, and this also needs review as an input. So if you use runnable lambda, this will run sequentially, right? So like if you pass all these functions inside the runnable lambda and sequence them using pipe operator, the first function will run, then the another, then another, then another, right? But all of three of these can run in parallel, right? So you can use directly runnable parallel for that, as we have seen in the parallel chain, and then we can use runnable lambda to do the sequential processing. So after all these three will run in runnable parallel parallelly. So I hope you remember this part, using runnable parallel to create a parallel chains. I'm doing exactly same here. Now build file and output is my last function, which I again pass to runnable lambda along with this parallel analysis, which is my runnable parallel, and that's how I'm creating a custom chain here. So custom chain is nothing, just using the runnables provided by the LangChain, like runnable lambda, runnable parallel, and using them to create your own flow of chaining. Like don't have to use the functions that are already provided by the LangChain. You can do basically everything using these two. So this is how you're creating another custom chain. So I hope you now know how it will work. Like initially this runnable parallel analysis, this will get triggered. It will trigger all of them parallelly, all these three chains parallelly, all of them will get executed. You will get the output in their following key value pairs, and then this whole object will get passed to this runnable lambda here, and this is how we are building our final output, which you are seeing in the response. So again, similar thing, a review, the sentiment, and then the summary, then issues. So issues are like appearance, frequent crashes, approach, and everything, then metadata. So this is how you create your custom chain. Now this is one last thing in the process of custom chaining, like runnable pass-through. This is another runnable provided by the LangChain, which actually helps you to keep the data plus adding something. So basically what you were doing here, let me go up. Yeah, here. So here you are keeping whatever is getting passed and adding something to it, right? So instead of doing it like this, you can just use runnable pass-through to do that. So let's see that. So if I just go to it, so runnable pass-through, it will just take a I'm just using the chains that I have created above in the example. I'm not creating them again and again. These chains I'm using here again in the example. So this is coming from the top block. So here I'm just saying runnable pass through dot assign sentiment chain, and summary chain, and issue chains. Then I'm creating a runnable lambda x, which is taking the review out of it, then sentiment, summary, and issues. So as you can see here, sentiment, summary, and issues, we know that they are coming from here, like we have written that here, right? So whenever this get executed, these three chains will get executed, and whatever is the output, this will be stored as a sentiment, summary, and issues. And this dictionary, this object will contain sentiment, summary, and issues. This is like clear. But this review, where this is coming from? So this is coming from here. So what is happening here in the runnable pass through, this object, this mapping as an input, this object is getting passed as a param in this runnable pass through function. So whatever is there in the object already, which is a review, this will be there, plus it will be adding these three to the same object. So the final object that will be coming out of this will be the review, as well as it will contain sentiment, summary, and issues, which is being used by runnable lambda here. So this is how runnable pass-through works. Like it will just, whatever is being passed into it, it will just keep that, and it will just modify that object, add things to it, and return it. So you can use runnable pass-through for such scenarios. So the last thing about custom chaining is chain decorator. So apart from these runnable parallel pass-through and runnable lambda, LangChain also provides you a chain decorator. So if you want to create a more complicated chain, like if you want to do many complicated things in a function, and you don't have to go like this, like creating different small chains, and then using runnable parallel and runnable lambda to create a flow out of it. You want a simple function, like a normal function, and you want to create a chain out of it. Like you can just do it using the chain decorator. So it turns a normal Python function into a runnable function, and it receives input, can call other chains, can contain business logic, and returns the output. So LangChain automatically wraps it as a runnable, makes it composable with LCEL, and enables invoke, batch, and stream function on it. So basically, this chain decorator, if you will assign this chain decorator to any function, all the methods that belongs to a chain, which is like this invoke and everything, they will get enabled for this function as well. So why do we use it? Because runnable lambda is best for like small transformation, one-liners, glue code, things like that, right? Like small stuff, like you have you can easily create small functions, like independent function, and you can use runnable lambda and parallels to create the custom chains. But if you have multi-step logic, like workflows and like complex logic, orchestration, and everything, then this chain decorator can be used in such cases where the logic is complex and cannot be divided into small independent code. So this chain decorator function, this has some rules around it. So if the function on which you can use this decorator, it should exactly take one input as an argument, and it should return a value like dictionary, string, and everything. So if any of these is not happening, you cannot use chain decorator around it. So inside the function, you explicitly invoke other chains. So in any chains that you are creating, you have to specifically invoke it, like in runnable lambda. So in runnable lambda, if you will see here, let me go back to a previous example. Let me go back. So normalized review. We have not done it here, right? Yeah, here. So enrich with sentiment. So we are passing enrich with sentiment in runnable lambda, right? But here we are invoking the chain explicitly, right? Same thing you have to do, because if you remember, in runnable parallel you don't have to do that. In runnable parallel, these chains get executed automatically, but in runnable lambda do not. So same thing with the chain decorator. So if you are using any other chains inside this function, you have to invoke them explicitly. Execution is sequential, deterministic, and easy to debug. So it's a sequential execution with this function. So let's quickly take an example. Again, a string output parser, then a sequential chain, a simple chain classifying the sentiment of the review, and then again the response chain. You are a custom support agent, sentiment is this, write an appropriate response for the review based on the sentiment. Similar chaining that we have seen above. Now here you can use chain decorator like this. So my review processing chain, it takes exactly one input and it's returning a proper output. So now this function can be decorated with the chain decorator. So as you can see, it's a normal function. Apart from this chain decorator, it's taking one input, doing things, like getting the review out of it, then invoking the sentiment chain to get the sentiment, then invoking the response chain and passing the sentiment as a and review as an input to the response chain, and then returning the final output as a review, sentiment, response, and metadata. Same thing that we had been doing above, but in different function and different chains. All of that we have clubbed together inside a simple function, and we are just using a chain decorator out of it. So now this whole thing can be invoked as a chain. Now this function has become a chain, and we can just invoke it like a chain. So invoke and pass the review, whatever the input is, and this will go here, and it will just execute this whole thing, and it will just return the output same as we have seen above, like a review, sentiment, response, and metadata, whatever you are returning from the function. So this is how you can create your own custom chaining functions, and that is all about chains in LangChain. In the next video, we will be looking into other stuff like loaders, splitters, and memory, and RAG, and there are many stuff that I will be covering in the next other videos. So if you will search on ChatGPT or anywhere, you will see a lot of other chaining functions provided by the LangChain. Like there is retrieval QA, and there is a there are many others, but those functions are like belonging to LangPoint 0.1. With the LCEL and LangChain 0.3, those are not recommended anymore. So like refine chain, map, reduce chain, so all these are not recommended in this LangChain 0.3 with the LCEL language. So all those functions, whatever they are doing, uh, there are other better recommended ways to execute those. So I will be covering all of them, like this map reduce chain and this rack chain, everything. Each of them is a vast topic, and I will be creating a separate videos on each of them. So I will be explaining everything just in small parts. I will not be covering in this chain section because they don't want exactly belong to the chains, and they have their own stuff. So just keep learning and practice all this. Then once you understand all the chains in the LangChain, then it will be easy for you to go through all of this, and then uh, enjoy your day, and please like, share, and subscribe the channel.